Hello everyone, welcome to day 16. Today we are going to be learning about conditional probability. So I'm going to go into the warm-up and then we'll go more in depth about what conditional probability is. So to start out with our warm-up, this is review from day 15, which was determining whether events are independent and dependent and then solving their probabilities. So for part A, it says selecting two aces when the first card is replaced. So remember when we're trying to determine if something is dependent or independent, you want to kind of look at those keywords as far as if something is being replaced. And in this specific example, it says when the card is replaced. So when it is replaced, we know that is independent. I'm just going to put I for independent. So now we'll go through and do our probability solving. So the probability of the first ace, well, we got to think of our denominator. How many cards are in the deck? But how much practice you guys have had, you probably have it memorized by now that it's 52. And then it's going to be how many aces are there how many aces in the deck are there? And there are 4 because there's one of each suit. Here they are right here. And that can be reduced to 1/13. So that's the probability of the first ace. Now we're going to do the probability of the second ace after we've drawn the first one. But because this is where determining if it's independent or dependent comes into play. Since it is independent and the card is replaced, that means after, let's say we drew an ace of hearts on the first draw and then we put it back in the deck, it's back in the deck. So there's still 52 cards. And since we put that one ace that we drew back in the deck, there's still 4 in there. And again, that reduces to 1/13. And now, when we're doing the probability of ace and ace, that's essentially what it's asking, 2 aces. You take both probabilities, multiply it by each other. And that's going to get you to 1/169. That's the fraction, but the decimal is 0.0059 or about 0.59%. Again, it just depends on how you round it, but in the quiz and homework, it will be more specific with that. Now for part B, we're selecting a face card and then a 7 when the first card is not replaced. So with that not replaced, that's the key there. So that is dependent. So now probability of face. And face cards are either jack, kings, or queens, cards that have a person on it or a face. So since there's 4 of each and there's 3 different face cards for each suit, that's 12 because 4 times 3 is 12. Or you can just count them all up here. But then our denominator, since we haven't picked one yet, is still 52. Now probability of 7, this is where it changes up a little bit. Because it's dependent, now instead of the denominator being out of 52, it's out of 51. Because when we drew, let's say we selected a king, the king of hearts. Once we pick the king of hearts, we're not going to put it back in the deck. So there's only 51 cards left. And there are 4 different 7s. Because again, there's 4 cards, or 4 of the same number or type of each suit. Now we'll multiply. We have 12/52 times 4/52. And that's going to be 48 over 2,000. Oh, I don't know why my pen is making all these little dots. 652. And that once, remember, you always want to reduce and simplify your fractions. So that reduces to 4. Sorry about my pen. I don't know why it's doing those little dots there. Over 221. So that is the fraction answer. Now we're going to move on to today's lesson. So with conditional probability, come on. With conditional probability, it's the probability of one event given and another event has already occurred. Now, conditional probability is the probability of one event given that another event has already occurred. So you're going to be seeing these different types of notations below here, and I'll try to help with memorizing it. So, or understanding it, I mean. So now it says the conditional probability of A over here on the right, given that B has occurred. So the second part is what has occurred. And A, or that first part, is the probability we're looking for. Let us say prob desired. And then this little dash, this little bar right here, that means given. That is what given that something has happened. And how you would go about calculating that is that you would do probability of them both happening, so A and B, and then you would have that B divided by the probability of B. So probability of what has occurred. Come on, pen. Sorry, my pen's been really glitchy, so I might have to just go to the mouse. So pardon, I apologize for my handwriting for the rest of the video. So that is what has occurred. I'm just going to do O for what's occurred, and then both and. And the same goes vice versa. So if it's probability of B given that A has happened, you notice that here that A is what comes second, so that's the denominator. Remember, B was for second, so B's denominator. And whatever is in this spot here is on the denominator. So now I'll do some practice. What is the probability that a person... So now we are going to be taking it out of this notation, or this as a word problem, and putting it into the notation that we saw, like up here. So now, what is the probability that a person prefers chocolate given that a person is an adult? So chocolate will be our A. I'm going to try the pen again. Okay. Chocolate, I'll say that's A, given that the person is an adult. So that's B. Remember, so probability of I'm just going to do chocolate, C for chocolate, given A for adult is equal to probability of chocolate and adult over probability of, and that's what's our denominator? It's going to be B, or B, so that is the probability of being an adult. We're not solving it right now, but we're just setting it up. Now for the second one, what is the probability the person is a child? So that's our A. Going back to my mouse, okay, bear with me here. So child is A, given the person prefers vanilla, so vanilla is B. So probability child, do CH for child, given vanilla is equal to probability of child and vanilla over probability of vanilla. Those are the different notations. Again, if you feel like you need to pause, again, I apologize for the handwriting. I can't get my pen to work. I've been having trouble, so I might have to use the mouse. But if you have any questions, feel free to email. Now we have a table over here to our right, and we're gonna be taking that notation and actually solve it. The probability that a person prefers prefers chocolate given that the person is an adult. So now remember how it's, so A is chocolate, so chocolate over here, probability of chocolate and adult, chocolate and adult, so that's 41 here, because that's where they meet up. Chocolate and adult, 41, over the probability of that there being an adult. So adult will go here, and that is 93. And if you're wondering where I got these numbers from, remember up here. So probability of A and B, that's where they meet up here, over the probability of B, which is just right down here, 93. And then, so that's chocolate and, so that's C and adult over adult. And that's going to be about 44, or sorry, 0.44 or 44%. Now, if the next one was the probability that a person is a child, given that the person prefers vanilla, so we got to do probability of child and vanilla. That's here, 26 over probability of just vanilla, which is 78. So that's 0.33 repeating, which is equivalent to about 33%. Because this is both of them, so child and vanilla over vanilla. I'll get some more practice here. Okay, so now we have another table. And it's probability of no medicine. So no medicine. I'm going to try the pen again. I tried to screw it back up and screw it back on. So, oh wait, it might work. Okay, so probability of no medicine. Let's see. No over here is 98. So this is back to the last unit. So 98 over in our total 200. So we have no medicine over total. And you're going to want to simplify that, but for the sake of time in the video, I trust that you guys know how to simplify it. I'm just going to continue moving forward. So probability of having the cold length be 1 to 3 days. I'm going to go to that over here and draw arrow. 105 over our total. And then probability of 1 to 3 days the complement. So that's it not happening. So I'm going to take our whole, which is 200 over 200, and subtract 105 over 200. And that's going to get you 95 over 200. And again, these can be further simplified, but for the sake of time, I'm just going to continue moving forward. So now probability of 1 to 3 days given that someone has been taking medicine. So remember, it's probability of both over probability of the given. So 1 to 3 days is here, and then that's going to meet up when we have yes. So 1 to 3 days, and yes, meet up here at 86. That's probability of them happening at the same time over probability of having taken medicine, which is 102. Remember, so that's probability 1 to 3 and yes over probability of yes. Now probability of no medicine. So no medicine and 4 to 7 days. That meets up right here at 79. Oh, my pen's not working again. Here comes the mouse. So 79 over 4 to 7 days, which is 95 here. Oh, that's a weird 90. Again, I really apologize. My pen has not been cooperating with me, so I'm using my mouse and cursor. Now, probability of no medicine, 4 to 7 days complement. You can still do that same trick where you take a whole, which is 95 over 95, because that's 1. 95 over 95, and subtract 79 over 95. And that will get you to 16 over 95. Again, so the only thing that's different about this specific day is that you're taking it's just learning how to read this table and interpret what this notation is saying here. So probability of A given that B has happened is probability of A and B over probability of B. So remember to do your note quiz, and then tomorrow you'll be doing your homework quiz. And if you have any questions, please feel free to ask.